So now I would like to move over to linear regression. I'm going to try to be a little bit fast because I don't want this to be so long. So for this, I'm going to create a struct and I'm going to call this linear regression. I hope I spelled that right. So this is going to be more or less on top of this struct would implement all our implementations for our linear regression. So it's going to have two attributes. I'm called one coefficient. It's going to be, I'm going to again use array1. And the type, of course, would be float f64. And the next thing I would like to, of course, have is will be an intercept. So again, we are doing just linear regression, so nothing so fancy. So I'll simply fit in a straight line to our data. That's really all we'll be doing, more or less. So now I'd like to implement our linear regression. So the first thing, of course, I would like to have here would be a new function that simply, of course, takes nothing and returns itself. And here again, linear regression, we simply populate it with some initial values. So coefficients, I'm just gonna populate it with array 1 zeros. So I can simply say array1 and then call the zeros method, and just shape is gonna be 0 for now. And of course intercepts, because it's a float, I'm just gonna make it 0 as well. So 0.0. It's fancy. And now I need couple functions. One would be a fit function. So this would more or less be what we'll be using to fit our data. So it's going to take a mutable reference to self, and of course then it's going to take some array. I'm better just call this data. So it's going to be of array view. I'm going to go for array view 2, and of course again the type would be just f64. I'm probably not going to go for 28 for now, or maybe I just call this x. So I'm just going to copy this part, call this x, and then y, because again it's only going to do linear regression for us, so we'll only have x and y actually. I'm sorry, this should be a comma, not a period. Okay, and then within the fit function, so what I'm going to do here is really going to be really straightforward. So I'll first extract the number of samples and the number of features, and then I'll create an initial array and populate those with ones, and then I can go ahead to, of course, more or less do take care of our fitting basically, because in the end, this is, if you think about it, this is like solving, of course, the equation of a straight line basically. So I extract the dimensions of my matrix like this. So I say x.dim to extract the dimensions. And of course, this should give me back a tuple. If I hover over it, of course, you would also see that what would get back would be a tuple. So, and I can assign those to, I'm gonna call this samples and features. So I'll say n and n common n features, and extract these both from the dimensions of the data. And now I would create an array more or less, or instead initialize a new array using this attribute that I just got, and I can call this, of course I want to make it mutable, so I say this with bias, and I'm gonna use my array to this guy array2, and I'm gonna populate this with ones. And in here, I need to, of course, provide the shape. So, of course, this shape should be a tuple. So in here, I'm providing my n samples and n features. Make this n feature plus 1. And now I have my x with bias. So now I need to perform some operations on our vector, on our array, more or less. the next thing I do is to perform an element-wise assignment. So I can say x with bias and say slice mute. Where is slice mute? And in here again, I'm going to use my handy macro. Is that imported? Nope. So of course I bring that in because that's also from ND array. And I bring that in, and now what I of course need to do would be to take a chunk to slice more or less our array. So I can do something like this, and then I go from 1, and now here I can just now assign this by doing like an element wise assignment. So I call the assign function, and then in here simply pass x by reference. And now at this point, we should be able to, of course, know the type of our x up here. Now, the next thing, of course, I will now to do, of course, would be to take our arrays and, of course, handle them as matrices. And then I do a transpose and then a matrix operation on those data points. So I can create a new variable. I call this xtx. So to, of course, notate what I want to do here, including the transpose as well. So I can say x with bias. I'll just call the t method, sorry, dot t for transpose. And when I transpose it, I now do a matrix operation. So that's why you have the dots, that is for matrix operation. And then I pass my x with bias like this. And I'm also going to do exactly the same for y, say xty for my y transpose. So I do something exactly. So x with bias, I transpose it again, and then I do a matrix multiplication, and then here now I pass y sorry, by reference. And now the next thing, of course, I need to do would be to create a solver. And the solver is just gonna do like I said, I'm not using any library, everything just pure mathematics. So I already did implemented the solver, and what I'm just gonna do is just copy it and bring it in here. Nothing fancy. I mean, you would, I guess, to some degree have some understanding of um, handling arrays and working with vectors and matrices and all that stuff to understand. But the important thing, of course, is that I first do a decomposition and then I do a forward and backward substitution. Again, you can see me here doing a lot of for loops because in this case, I have a multi-dimensional array and I'm taking care of that. So if this is not clear for you, then I think spending time in this tutorial might also not help so much. Or if you're not familiar already with, or if you've never had to work with matrices and all that, this might be kind of like difficult for you to understand. But in the end, basically what we are doing here is just a simple trying to more or less solve, of course, our multi-dimensional array that we're providing in here. And then, of course, do some decomposition and then do some substitution. That's really what is going on in here. So with this solver method implemented, what I can now do is, of course, to extract my coefficients. So I can simply now call my solve method, and I pass my, I need to pass these two values that I just created. So one is this xts, I can call the view method on it. And then, of course, xty.view, and sorry, and now I have my coefficients, and then with my coefficients I can now actually set up my intercepts. So I can now say self.intercept. Oh, come on, what did you do? So self.intercept, I'm just going to take my coefficients, just the first value, and of course I also need to provide my coefficients. So I say self.coefficients. And for this, again, I'm just going to more or less make this a slice. So I say coefficients dot slice. I provide a function, and in this case, I'm going to again use my macro, this one. And then in here, I'm going to start from 1. and of course dump the rest. And I'm giving it ownership of this. So like this. And we seem to have some error over here. Let me see. And the last thing maybe I would implement here more or less would be to just add a simple function for prediction. And I can simply call it predict. Sorry. So again, you're going to, of course, take reference to self. And you should be able to provide an array. So I'm going to use array 2, or maybe array view actually. And then of course it's gonna, again, the type would be F64. And what I'm gonna return in the end would be just array, come on, array 1, again F64. And what we're going to do, again, if you think about the prediction here, we'll simply just to do to more or less try to find the basically solving a straight value equation, straight line equation basically. So here I can do a matrix multiplication. So that's why I'm using dots, and I need to take my coefficients, and with my coefficients I can add my intercept. And this way, pretty straightforward. I would, of course, for this array, be able to predict the next value going forward. Okay, so that's mostly what I would want to implement here. I could also maybe implement a function for basically scoring our prediction, but I would see if we have time. If we have, we do. If not, otherwise we can just leave it out. So I'm gonna keep it straightforward so we don't actually lose so much time. So let's proceed. The next thing, of course, I would like us to do would be in evaluation. So I have this done, neural nets. I would see if we can do this with the time we have. But the important thing, of course, that I also need to do would be within this evaluation module. So in here, I would like to define a few functions. The first one would be, I would like to, of course, calculate some of the possible errors we would like to check. So one would be our mean squared error, and it's going to return F64. Then I'm just going to maybe, no, it's fine. So the next one, of course, would be our root mean squared error. Again, it's also, all of these errors are going to be returned as F64, so it's fine. And what am I getting? Also pub, of course, pub fn. And the next thing would be mean absolute error. So mean absolute error. And what else? Maybe I also calculate an R-Squared. R-Squared. Again, F64. And what else? What else? Maybe I would like to adjust my R-Squared. So I can create a function called adjusted R-Squared, like this. And what else do I want? I think that's mostly all would be needing basically. Maybe one other thing I would do is just to create a function for printing my evaluation matrix. I can create a function called print evaluation matrix, like this. It's not going to return anything. And I can also have another one for statistics. So I can say pub fn print statistics. And again, it's not going to return it. It's just going to print to the standard out. And maybe the important function I would need to also provide here would be a function for actually plotting our regression. So I can just call it plot regression. I'm just gonna keep it as this for now. and we can actually start making our implementations. Because I think the plot regression, I've also implemented this. So I'm just gonna also copy it and paste it here so you see what it could look like. I will also try to explain it a little bit, but let's start with our mean squared error. So for the mean squared error, we would basically take two values. So one would be, we want the actual value. I'll call this y true. It's going to be of array view 1, and the type of course will be f64. So it's going to take this true value and it's going to take a prediction value. I'll make them actually the same. So rv1 f64. And what we do in here is also quite straightforward. So we go through our r true. And what I want to do is, of course, turn this into an iterator. And when we have an iterator, I would like to, of course, zip, because I will need to perform like a operation, of course, with our prediction value. So ypred.iterator. So we turn this into an iterator. And then with these two now, I can call the map function. And in here, I'm just going to again provide a function basically that takes what is going on. Okay, a function that takes two arguments. So I'm going to provide a reference to y true and another reference to yp. It's going to be, of course, prediction value. And then what I will need to do would, of course, be to this is how you calculate the mean square error, not root mean square error. So I subtract the predicted value from the true value, and then of course I square the result. So I simply say power, and I just provide 2. And so of course we have to do this for all the values. So when we've done it for all the values, we simply sum everything together. Again, I'm going to provide a type here because it's going to be of type F64. And what I can now simply do in the end, we just to divide this by the length of our y true. So y true and dot length. And again, I also make this cast this also as F64. My IntelliSense is completely frozen. And that's all we actually need to do to implement our mean squared error. So for root mean square error, it's also really in the name. So we simply just find the square root of the mean squared error. That's really it. So we can simply call the mean squared error. No, what did you do? Mean squared error. I'll provide our y through and y pred, and then come on, and then we simply find the square root. Again, I'm just gonna copy these two guys, pass them as arguments in here, and that's how we actually do our root mean square error. Basically, it's the square root of this one. That's it. And for the mean absolute error, it's also going to be similar to the ones we have above. So again, it's going to take the same argument. And now again, something quite similar. So we look through our y true, and again we turn this, oh come on, this JavaScript stuff. We turn this to an iterator, and then of course do a zip. And then for the zip again, I'm going to pass ypred as an iterator. And then I also do, because now I want to perform an operation on all of them. So again, I do a map. So for the map, I'm also going to provide an argument similar to the one we have above. So again, an anonymous function that takes two arguments. One would be a reference to the true y, and the other would be a reference to the predicted value. So with these two in hand, the equation is a little bit different. So what we need to do is basically subtract the predicted value from the true value, and then we simplify the absolute value. That's the it's also in the name. That's why it's also called mean absolute error. And now when we have this again, we sum. Again, we provide a hint for the type. It's going to be again F64. And again, just like we did for the other one, I will also divide this with the true length. So y true dot len, and I'll also cast this as 64. That's really it. So this is us implementing all of these errors that we'll use in the end, of course, to do our evaluation. So for the R-squared, it's also going to be pretty straightforward. I will first find the mean of our predicted values. So I think I still have it copied. Okay, so now in here, I can get the y mean, call this y mean. So y mean would be equal to y true, and then I call the mean function on it to get the mean. And of course, I handle any possible error that might arise. And then of course, I need to now get the total. So I can create a value called as tot. And then again, I go through my y true. So from the y true, again, I iterate over this. I turn this into an iterator. And then with the iterator, again, I can perform a map. So within the map, again, I pass an anonymous function. The anonymous function should be able to just take one argument. So I'm just going to call it y. I'm going to send it off, pass it, of course, as a reference. And now what I can simply do is subtract y mean from this value. So this is going to be like more like a deviation from the value, basically. And then I, of course, square this. So I use the power, and then the value would be 2 for squared. And then after the map, what I need to do, of course, is to, again, to sum everything up. And again, I can also typecast this again as F64. So that's how I get my S dot, of course. And now what I can also do is to basically, I can calculate like a remnant, basically. So I can create a new variable and call this, I don't know, res. Okay, and now this would be, again, I'm going to go through my y true, and I can iterate over it. Again, I'm going to, of course, need the predicted value. So I'm going to zip this with my ypred, of course, turning it into an iter. So with this value, I can again do a map. I can again do a map and pass an anonymous function. So the anonymous function, again, is going to take 2 arguments. So I'm going to call this yt for y true, and then again yp for ypred. And with these 2 values, again, I'm going to find the difference. So I can simply say y true minus yp. And with this part, with this value one more time, what I can also do maybe is to calculate the power again. Again, it's going to be to the power of 2. So I'm basically squaring this. And then with this, now I can again calculate the sum. And I'm again going to type this. So F64. And at this point, all I simply need to do now would just be subtract the coefficient, the division, like divide these both, and of course see the deviation from a whole number. So I can simply say 1 minus 1.0 minus, and in here I can say SS res divided by SS tot, like this, and that would be our R squared. And so for the adjusted R squared, it's also going to be quite similar to this. So again, I'm going to copy this, pass that in here. And now I also need to pass a feature size. So I'm going to call this end feature. End features. So for now, I'm just going to make it U size. Okay. And what I would like to do in here would simply just to compare this with my R-Squared. I can create a new argument called n. So this would be, you know, me just getting the length of the y true. So I can simply call the length function, and then I cast this as float f64. And now what I can simply do is to calculate my R2 again, which is going to come from R squared. I pass our y true and y pred. And now what I can simply do again is 1.0 minus, I now again subtract this 1.0 minus my R2, which I just calculated. And then I multiply this by n minus 1.0. And then I divide this again by the deviation from n. So in this case, it's going to be n minus number of features. And I'm going to cast this as f64 minus 1.0. So this is just some mathematics basically. Maybe what I can also do would just be to paste the equations. For you, I can maybe just add them in the README, or I don't know, provide a link. So if you want to, of course, read through how this is actually defined, feel free. And maybe you can also help me to point out differences that are in my implementation. I basically just wanted to get my hands dirty, and then, of course, implement this myself and see what I'm going to get in the end. Okay, so for the plots, like I said, this is already implemented. This is one thing I know that could take a while, so I had to take the initiative of implementing this before now. So I can explain this is not so fancy. I would say the only thing, of course, would be that in this case, this is a new library that you're not familiar with, but of course, if you've done anything in Python, you would probably, of course, do this with matplotlib. So in this case, I'm using plotters, which is the library. And so again, I'm just getting more or less trying to define the ranges of my plot. So that's why I'm calculating the min max, these min max values. And other than that, I have this handy function chart builder. And chart builder should of course come from plotters. So I think my IntelliSense is quite slow, but I need to bring in plotters, the prelude. So I can say plotters.prelude, and I bring in everything. Go away. And maybe I can also do, I think I used point series, so I can also bring this in. So this should come from plotters, from series, point series. Anyways, so I get those min max values, and then of course I have this handy chart builder function that allows me to provide things like caption, margin, label size, and also basically just beautifying the whole thing. And then of course this is simply the draw function, and in this case what I'm doing of course is adding two charts into our chart. So that's also why you see one here is labeled as true values, and the other one is labeled as predicted value. So that's basically what is happening here. Nothing quite so serious, of course. Again, if you look over here, we have this bitmap backend defined. You could see here that I have to provide an output file path, and of course the size in this case is going to be 800 by 600. This would of course be my drawing area. So that's really what this function is. Again, I didn't want this to take so much of our time, so I took the initiative to more or less write this. And for this matrix, I've also written this because it's just going to be some bunch of tests. So I took the initiative to write this again, so it saves us some time. So it's basically just printing those calculations, nothing fancy actually. And for statistics as well, it's also the exact thing I'm doing here. So again, making those calculations and then printing them. So the only thing I would now do, of course, for statistics would be to bring in the crate. So I need to just come in here and say use crate. So, and I go to statistics, and all these errors should go away if my IntelliSense is okay. Now it's with us. I'm gonna leave out neural nets. It's also even a crazier implementation of what I have, but I will also like to share this source code, of course, with you, because again, if there are people out there who would also maybe like to have their implementation, like basic mathematics, mathematical implementation, maybe you can also be able to look through maybe my own source code, give a comment or whatever, just say, or basically just maybe have this as a starting point, and then maybe make additions and all that going forward, but it's really fine. So I'm just going to come into our main file, because now I would like to start bringing everything together. So I'm just going to change this function to main. I'm going to get rid of this test. I don't need it anymore. And so the main function is really not going to take anything. So I'm going to remove this again, and return wise is going to just return a result. So it's going to return a result. It's going to probably return nothing if, well, everything goes well, and it's going to return, of course, yeah, an error, which could be anything. So that's also why we're using the box smart pointer here. So I use the dyne keyword because it's going to be dynamic. So now go to std error. So if we get an error, we should be able to propagate this back to the user. So we're going to do this in steps. So say, so now we load and process data. So I don't know, something like this. So I create my data set. My data set is going to come from, I simply call the load CSV function and provide a path. Or maybe I can actually provide that path in here. And so when this function is called, we have to provide it. So it's going to be string. So of course I close this up. And then maybe in the end, just to not have this shout at us all the time, I'll just put OK at the end. So this should silence this error for us for now. Okay, so I have my data sets like this, but of course I need to modify this, because if you remember, we had this normalize function, sorry, that takes a data set um, like this, and of course we need the features. So should be able to do data sets dot features. I think we named it features. What is the problem? It's data sets. My IntelliSense is really messing up. What is the error? One of the same, blah blah blah. Why do I get okay? So first of all, I have to make this mutable, so this has to be mutable, and of course what we need to pass in here would also be a mutable reference. And so what I can do is maybe go here, and features, of course, is features. Yes, of course. Oh, my bad. Our data set is still a result. So again, because we are now returning a result, I should be able to do something like this. So now we are passing features, of course, to our normalize function. So this should be able to normalize our data for us. And now the next thing I need to do is maybe I add the comments. I'll split data to test train, and I can simply create a tuple like this, and I have my train data and tests data, and this is going to come from our train test split. So we simply pass our data tests and the test size. For test size, I'm gonna maybe say I want to use 0.2% of it for testing. So we're gonna use the rest 80% for training. In some cases, people like to go the 70-30 way. It doesn't really matter. You're welcome to do whatever it is you would want to do. It doesn't really matter. And so once we have so we have splitted our data, so now we can actually go ahead and do some regression. So here I add a comment for linear regression. So in here, maybe I can also add for some comments and say performing linear regression. Okay, and then what I can now simply do is, of course, to instantiate our linear regression. So I can simply call it maybe LR model, and this will come from our linear regression. So I can say linear regression.new. And now we have our model, and now I can do all the things what I would like to do. So I can now do LR model.fit. For fitting, I would like to pass my train data and the features and the targets. So I'll pass my train data, train data.features, and I can of course use the view function, and then I can also basically do the same for targets. So again, train data dot targets, I can again call the view function. And now, of course, this I should make this mutable actually, so I can make this mutable, and this error should go away. Okay, so after fitting, what I would like to do would be to get my predictions. So I can say let predictions. My predictions is simply going to come from my predict function. So lr model.predict. And to predict, of course, I'll need to pass my test data. So I pass my test data, and I pass my features. And again, I use the view function. Of course, I need to close this out. And now I have my prediction. So now what I would probably need to do would be to evaluate predictions like this. Maybe in here I also add a comment and say make predictions. So when I've made my predictions, what I would like to do, of course, the reasonable thing would be to evaluate the prediction. So I'll first need to calculate my mean square error and R2. So I'm going to say LR. This will be my mean square error. So mean squared error. And for my mean squared error, I need to pass my test data. So tests, what did I call it? Yes, test. Oh, sorry, test data, and of course, targets. Oh, dot view. So I pass my targets, and of course I need to pass my predictions. So now predictions, and I can also call the view function. And now I have my error, and I can maybe actually just copy this part, I guess, and create a new argument. So this would be LR2, and this would be from R-Squared. So I can just replace this. And this should be able to, of course, calculate the R2 for us. And maybe what I can now do is, again, I can print this out to the user, and I can say mean squared error, and I pass the mean squared error. And this would be, of course, our LRS, this one. And again, I can do exactly the same for our R squared error. And again, I pass our LR to this guy. So at this point, we should be able to see our errors. And the next thing, of course, I would like to do would be to plot out our regression, basically. So I can call the plots regression function. And I want to get rid of all of this first. Come on. And now I can pass the data, basically. So I need to pass my test data. Of course, I need the features. And again, I can just provide the column. So I can say column, not columns. And I use the index as 0. And the next one, of course, will be my while true. So test data dot targets. I can say view, and the next will be prediction. So I'll provide my LR. What did I call it? What did I call it? Simply predictions. So predictions, again, that's view. And the next thing, of course, would be the output file. So I can give this a name. I can call it linear regression .png. So this would be the name of the file that would have this saved for us in the end after the plot has been generated. So maybe I can also add a comment here like plots regression. It's already in the name of the function, but that's also fine. If we do it like this, why do we get an error? So of course, this returns a result. Again, I can simply handle it like this, and this should be fine. And so now the next thing I can do is to just add those print comments. So I can say print evaluation metrics. I can pass again tests data dot targets. Sorry, not text. Tests data dot targets. And of course, add the view function because okay. And then for predictions, I'm just gonna again pass my predictions dot view. And then for features, I'm probably just maybe gonna say 2. And then the next function will be to print statistics. And for this again, I'm gonna pass my tests data dot features, and I can also use the column function, the first column. And for y, I would pass my target values. So tests data.targets, and I can call the view function. So this is one way we can actually utilize most of what we've done so far. It seems we have, okay, we did not, maybe I can also maybe to make this, I don't want to have any comments about unused code. So I can simply say something like the headers of the the headers, it's already fine tuning. No need to think too much about this. So header, actually this should be headers. Let's try to be grammatically correct. And so that way we should be able to see the headers printed on the screen for us. So if we go back to lib, this should be able to, we should now be able to load our data, normalize it, split it into test and train, perform our linear regression, do some fittings, do some predictions, and then evaluate our predictions, make our plots, and again at the end, do perform some statistical evaluations and then bring this to the screen. So that's basically what this whole thing would do for us. So we can actually now, I can maybe call this ML learn. So this will be our function. And now I can go to main because now this will be in our crate. I can bring this back. And now I don't need this anymore. Now I can say ML learn. That's ML learn. And now I can actually provide a name of a CSV file. So I'm going to call this something like scores. That's CSV. I have also provided prepared a CSV file, which I'm just going to bring in now for us to basically check it out and see how it's going to perform. So I've gone ahead to provide this CSV file. As you can see up here, it's just called scores. It has a header. That's really nothing fancy here. Just added some random values basically, and if you can also see here, it's really not much. So I doubt that the prediction would be so great. But what I can also do is maybe to generate some more random values and then dump them in here. And then we also see how that's going to behave. Anyways, let's come back to our main file. We have our function now. And of course, it's really not doing much. So I'm just going to maybe assign this to basically nothing so that this one at least can go away, because again, this is returning a result. but that's also totally fine. So I can maybe even get rid of this. We don't need this anymore. So this file is called scores.csv. So that's also what I've provided here. So we can now test this out to see how it's going to behave. So I can say cargo run, and it's going to build for a while and then run. So now you will see here, if I expand this, for example, we see our headers, which is probably the first thing we log to the console. We see performing linear regression, so it calculates our mean squared error, our R squared error, and then it evaluates some metrics for us. So mean squared error, root mean square error, absolute error, and then of course this R squared that is also the one exactly up here. And now we have, of course, this adjusted R squared. And now some of the statistics that I added was just this mean. I think I gave all of them the same name of mean. So let's look at that real quick. So I can come back into statistics. No, I think it's that data processing, I guess. Was it? No, evaluation, I guess, hopefully. Yes. So this is mean. Sorry, my bad. So I was copying and pasting, unfortunately. Standard deviation. So this would be covariance, and this would be correlation. Okay, so that's basically it. So now I can actually just run this one more time just to show you that. And now this should, of course, print out the results for us as correctly as expected. And now we also have this file created for us called linear regression. So if I expand it, of course, you also see that it's not quite perfect, which was also what I told you, because we didn't actually have enough data. So, but it still tried to fit this based on the data we have. So you can actually see this is pretty straightforward, and also goes to show that you can actually do data science if you are a Rust developer. If you, like me, love Rust so much and almost want to use it for every other thing, you can maybe give this a shot. Of course, if you ever feel that there is any need for you to do so, because for my own case, at some point I need to do some data analysis, some like really large data analysis, like analyzing some like really large data, like running into like maybe hundreds of gigabytes or so. So I really love to leverage Rust and of course Py 3. So if there is already some functionalities, maybe that I have to maybe collaborate with other developers that are already in Python. Of course, I leave that as it is. But for the core logic, I have the option of maybe writing this purely in Python and maybe using Py 3 to output a Python module, and then of course add this into the project. And again, this is going to really speed things up for us. So anyways, guys, that's really what I wanted to show you. And if a lot of things are really not so clear for you, again, I'm going to provide as much information as possible regarding those errors we calculated to show you the mathematics and everything, so you can check it out if you want. And if some of the APIs are also new for you regarding work with polars for manipulating and handling data, I'm also going to do a different video on this to show you how you can like holistically handle this. So I'm just going to do a different tutorial just working on polars for you, so you can see how you can actually work with this. So the point for me really is to share with you as much knowledge as possible. So as soon as I acquire those knowledge, I give it out to you already, so you can have it as well. So anyway, guys, that will be all. This was really becoming a quite long one, and I never really anticipated it, but it's still fine. In the end, the information now is out there for you, and you get to consume it whichever and whenever you want to. Anyway, guys, that will be all for now. Again, if you're new, just go ahead, subscribe, turn on the notification bell, and you'll be notified each time we have a new content. If you have questions, please feel free to reach out, ask them, and yeah, I will get back to you as quickly as possible. Anyway, guys, that will be all for now. Until we see each other next time, have a lovely evening, guys. Stay learning, and bye bye.